Hello students, in this video we'll see an example of using Lagrange multipliers to find the maximum and minimum values of a function subject to a constraint. Let's be given the function f of xy, which is xy squared, and I want to optimize this function, optimize f subject to the constraint that x squared plus y squared is equal to 4. Now we can turn this into an ordinary Calc 1 problem, but let's approach this through the method of Lagrange multipliers. The method of Lagrange multipliers says take this constraint over here and treat this as saying that g of xy is equal to a constant, in this case 4, and we show that the gradient of f has to be proportional to the gradient of g. So the method of Lagrange multipliers asserts that the gradient of f is a multiple lambda of the gradient of g. Now we compute both of these gradients. So the gradient of f is going to be what? The gradient of f is going to be x. The gradient of f is going to be what? Not x, but it's going to be what? Gradient of f is going to be the x derivative of this function. So the gradient of f, the x derivative of this is going to be y squared. Then the y derivative of this function is going to be a 2xy. And that will be lambda times the gradient of g. Well, g is x squared plus y squared, so the gradient of x squared plus y squared is just going to be 2x and then 2y. So now we can write down what these equations tell us. These equations tell us that y squared is equal to 2 lambda x. And the second equation tells us that 2xy is equal to 2y lambda. So what does that tell us? That tells us, well, we could have that y would be equal to 0. In this bottom equation, we could have that y is equal to 0. And if y is equal to 0, then x is equal to plus or minus 2, and the function is equal to 0. So if y is equal to 0, the function is equal to 0. So let's assume that y is not 0 and keep that in the back of our mind. So I can cancel out the y and cancel out the 2, and that tells us that x is equal to lambda. Well, if x is equal to lambda, then the top equation over here tells us that y squared is equal to 2 lambda times lambda. So in other words, y squared is equal to a total of 2 lambda squared. So x is equal to lambda, and y squared is equal to 2 lambda. Let's use this in our constraint over here. Our constraint tells us that x squared plus y squared is equal to 4. So x squared, we know that to be lambda squared. And y squared, we know it to be 2 lambda squared. That has to be equal to 4. So that tells us that lambda squared, 3 lambda squared is 4, so lambda squared is 4 over 3. So lambda is going to be plus or minus the square root of 4 over 3, or 2 over square root 3 plus or minus. So what that tells us, that the x value is going to be what? Is going to be plus or minus 2 over the square root of 3. Once we have x, we can conclude what y is. So y is going to be 2 times, well, y squared is going to be, well, we know what y squared is, and that's what's going to matter for our function. Our y squared is going to be is going to be 2 times whatever lambda squared is. That's going to be 2 times 4/3. And so y squared is going to be 8 over 3. So for our function, if we have these two critical points, right? Namely the square root plus or minus the square root of those points. And so we can conclude over here that if I look at f of what? F of 2 over root 3 for my x, and for my y, I'm going to look at the square root of 8 over 3. That's my y value. Will be what? Will be 2 over root 3 times 8 over 3 for y squared. And so that's going to be a 16 over 3 root 3. And similarly, I get the same thing for plus or minus, right? So if I have plus or minus in here, it won't matter because the y squared is going to output an 8 over 3. And if I look at f of 2 over root 3, with a minus sign, the other point, and then either plus or minus the square root of what? Now what will y squared be? 2 lambda squared, still that. Square root of 8 over 3. What we'll have is we're going to have a negative 2 over root 3 times 8 over 3. So we'll have a negative 16 over 3 root 3. So this point over here is going to be the what? That's going to be the maximum value Now you might say, what about 0? Well, if we plug in 0 over here, I'm going to get a value of 0. And clearly, 16 over 3 root 3 is larger than 0, so that's definitely bigger, so that's going to be the maximum value. And negative 16 over 3 root 3 is definitely smaller than 0, so that will be our minimum subject to the constraint. That's the max subject to the constraint. And this value over here is the minimum subject to the constraint. Thank you very much.